And what is it?
This is from 3.3, number 5.
3.3, number 5.
A of t is equal to 1 over t plus 8 on 9 and 9 plus h.
Okay, so the interval is 9, 9 plus h. What was the problem with this situation?
I tried plugging it into the formula, and none of it was working. It kept showing up as an incorrect answer. And
so first of all, we're asked to find the average rate of change, right?
Right.
So the average rate of change will be a of 9 plus h minus a of 9 over 9 plus h minus 9. So what was the problem next?
Well, I plugged all the information.
Okay, so what is the first one?
Hang on. I throw away all my notes. That would be, yeah, right. So the first one would be 1 over 9 plus h plus 8.
Exactly, of course. Minus?
1 over 9 plus 8.
1 over 9 plus 8, which is 17.
Right.
Good. So this one is 1 over 17, or I will say h plus 17, and the other one is 1 over 17 divided by h.
The problem came when I was trying to bring that h in the denominator up so I could actually solve it.
It's h over 1, right? But you have to
Right.
you have to find the difference first. What is the least common denominator?
H plus 17.
Careful. Careful. Of course, they have nothing in common. 17, 7. That's why I'm asking. Did you put this least common denominator?
Mm-hmm.
Good. So then what is the adjustment for the top of the first one? Good. And the adjustment for the top of the second one?
Oh my gosh. How could I be so stupid?
That's okay. So this is 17 minus h. So then negative h divided by 17 plus h times 1 over h, and we simplify the h. As we've noticed, everything without h went away. So the answer is this.
Okay.
So please be careful how you add and subtract fractions. You cannot just find the least common denominator and just add or subtract what's at the top. Remember, we change the denominators, then we have to change the numerators. Questions on this? Okay, let's move on to the next question, please. Is there anything else? Deja, I think you had something? No?
Oh, no.
No? Okay. Next question, please. Anyone? Yes, please, Mike.
I don't remember what the assignment is, but the question was, is x squared plus y squared equals 4 a function?
Good. So when we're given an equation and we are asked to show whether it's a function or not, what do we need to do? What do we need to do? We need to
find y.
Exactly, solve for y. Solve for y. Excellent. Thank you, Imran. So then we have y squared equals negative x squared plus 4. We take the square root. First of all, how many solutions do we have to get?
2.
Of course. So we get y equals? Very good. Plus or minus the square root of negative x squared plus 4. It's sufficient to say when x is 0, I get y equals plus or minus 2. It's sufficient to just show one x value for which we get 2 y values. What do we conclude about x squared plus y squared equals 4? Right. And we already know what this is. Can anyone identify it?
Circle.
Very good. It's a circle. So obviously cannot be a function. And the center is?
0, 0.
Okay. Perfect. And the radius is? 2. Awesome. So the circle is 2 functions. The function from above with plus in front, the square root, and the function from below with minus in front of the square root. Excellent. Anything else? Mike, is this okay?
Yeah.
Perfect. Anything else for me?
Maybe on the 3.4.
Anything from anything? You tell me.
So it was number 7B.
Number 7b.
Mm-hmm.
Good.
About floating functions again.
Yes?
And so they had find P comp M of X.
P of, oh, yeah, okay. P of f of x.
Yeah.
Okay, or P comp f, very good.
Okay, and
P of x was, and f of x was.
I think P of X was 1 over the square root of X,
Perfect.
and F of X was X squared minus 4. And it was asking for the domain.
Okay, are we asked also to find the function or not, or just the domain?
Just the domain.
Oh, excellent. So I don't need this. Perfect. So remember, what I do need is to identify which function is applied first. That's why I need it. I'm not going to calculate it. We do not determine the function composition in order to find its domain. Never. Please remember. We do not find the function in order to find its domain for function composition. Okay. But what is important here is to know that f of x is the inner, which means will be applied first to x to get f of x. That is crucial. And then p of x is the outer, which will be applied second to get p of f of x. Okay. So here's what I need to determine. I need to determine the what for f. Domain, very good. I need to determine what for f. Excellent. And I need to determine what for p. Excellent. Great job. So now, look at f of x. F of x is x squared minus 4. And I need to determine the domain of this function. We should not think of polynomials. For polynomials, we can never think about the domain. Thinking is not required when we talk about the domain of polynomial functions. There is no thinking involved here. Right? Okay, but now when we talk about the range, that's a different story. So I know this is negative infinity to infinity. No questions there. Okay. But now when we talk about the range of function f, that's a different story. I have to picture the graph. We're going to talk about transformation. So I need this function. I know that this is x squared, correct? At 0, correct? And it's down 4. What is the range of this function? Yes, you can graph it with a graphing calculator, but I'm just anticipating the transformations. Very good. So now I have this piece, which must be, or it will be, negative 4 to infinity. Now what I'm concerned about is this function. I need to find its domain. Excellent. So let's look at that function. So p of x, I'm going to copy it here. Good. It's our best friend now. So domain of this function.
Restrictions.
Correct.
So it would be X is greater than 0.
Excellent. It cannot be 0. It's in the denominator. So the domain of function p is 0 to infinity. Great job. Oops, I have a problem. A big one. This should be 0 to infinity. What does this mean? It means that some numbers here bring here between negative 4 and 0. And that's a problem. Because for numbers between negative 4 and 0, p cannot be applied. P can be applied only from 0 to infinity, not for negative 4 to 0. So f of x between negative 4 and 0, I need to solve this inequality in order to find out which x numbers make f of x between negative 4 and 0. So okay, I can exclude them from here. So f of x is 1, it's x squared minus 4. I replaced f of x by x squared minus 4, and now I'm trying to solve this compound inequality. Let's solve this first one first. So this is number 1, and this is number 2. Which one? This is not how we solve quadratic inequalities. Careful, careful, careful. We did a problem last time. We looked at a problem last time. So let's solve this one first. X squared minus 4 less than or equal to 0 means x plus 2x minus 2 less than or equal to 0. We have to study the sign of this product. X is the variable in the problem. X plus 2 is the first factor. X minus 2 is the second factor. And then x plus 2 times x minus 2. Yes. Thank you. Okay, when is the first factor 0? At -2. Where is the second factor 0? These are the numbers I need to put in the table. X plus 2 has a 0 somewhere here. Under which number? Excellent. X minus 2 has a 0 somewhere. Under which number? I know it's silly. And now the product, what happens to the product under -2 and under 2? Of course, the product is 0 and either one is 0. Remember what we said? These are linear functions with a positive slope. They look like this. Which means from negative, they cross the x-axis and they go positive. From negative, they cross the x-axis and they go positive. I need you to multiply two negative numbers because that's what we do. We multiply these numbers and I just need the sign. I need you to multiply these two and I just need the sign. And I need you to multiply these two. Okay. This tells us which sign we pick. Which sign is less than or equal to 0? Good. So what will be the solution of first inequality? Right. So the first inequality, x in the interval -2, 2. This is the solution only for this portion. We didn't get to the second one yet. Let me remind you what we're doing. We're trying to find the domain of a function composition. It's a lot of work. Okay, now I'm solving the x squared minus 4 greater than or equal to -4. And this one I like because x squared greater than or equal to 0 is always. Yes? Anything you plug in will be greater than or equal to 0. 0, yes. 1, yes. -3, yes. Everything. No problem there. So now, because I want this to be fulfilled, I will have to intersect this with this. This is always for any number. So finally, I will say I must exclude what from the domain of f of x. 3 pages ago, we looked at the domain of f of x. It was this. But now what do I have to exclude? What do I have to exclude from the domain of f of x? Exactly. -2, 2. -2, 2 is the culprit. F applied to -2, 2 will bring here numbers from -4 to 0 that do not work for p. But if I exclude -2 to 2 from here, it's out. Then anything you apply f to, from -infinity to -2 union 2 to infinity, will never bring -4 to 0 here. Will only bring guaranteed 0 to infinity. And that's the domain of p. And that will be the domain of function composition. So result. Domain of function p comp f is -infinity to -2 union 2 to infinity.
That's the answer.
Yes. Yep. So let me just say one more time and we can put this to rest. F applied to any real number results in -4 to infinity. So if I pick a number here and I get 0, or let's say -1, P cannot be applied to -1 because the domain is 0 to infinity. So I can never get here. So those numbers that F applied to bring -4 to 0 now are excluded. They're not here anymore. Since they're not here anymore, they will never, F will not be applied to -2 to 2, and the result here will never be -4 to 0. Therefore, it will always be 0 to infinity, which is the required range. So then P can be applied to 0 to infinity and get here. I do not consider this a trivial type of problem. Yes, please.
How do we get -4 and infinity?
The range of this function. This is x squared down 4, from -4 to infinity. X squared minus 4.
Like, is there any way to calculate this or like?
You need to know that, but I can show you what the graphing calculates. The transformation on x squared. Bless you. So x squared minus 4. So yes, this is something that we need to know. Okay? So the range of this function is from -4 to infinity. We're going to talk about it again in transformations. So that's how we get -4 to infinity. And the range of this, of the domain of P is 0 to infinity, so -4 to 0 has to go. They can never be here. -4 to 0 can never land here. Very good question. It's a very long one, so it's for homework, obviously. Okay, anything else? Caleb, is this okay? It's the only way. It's the only way. We have to determine the domain of first function, the range of the first function, the domain of the second function, and we have to see what happens in there, in the middle. So this one was bringing -4 to infinity, but this one could not be applied to -4 to 0. So we had to remove that, but in order to remove the -4 to 0, I had to go back to the original set and remove those values that bring -4 to 0 in the second set. And by removing -2 to 2, it's guaranteed that the range of function f will never, ever have anything else but 0 to infinity. Strict 0 to infinity. Very good. Okay, next question, next problem. Is there anything else? Okay, this is an old test. Not everything pertains to this because, as I mentioned, as you already know, we just recently, last year, last semester, I believe, we went to this new textbook. So this is just a sample from the past. Now, I'll tell you what we have not covered, because that's easier. We have not covered something like this. We will, but we haven't done it. Rationalizing the numerator, we know how to do that. All these equations, yes. The inequalities, I would say no to this because this is a rational inequality and we haven't gotten the chance to talk about it. We talked about quadratic inequalities and polynomial inequalities, but not this yet. This is the situation with lines. It does come in a little bit later. We have not discussed it yet with modeling, but I think we did determine the equation of a line, didn't we? Determine the equation of a line given 2 points? Yeah, so that's all it is. We can do it together. We did something like this. This is the difference quotient, mandatory. We graphed piecewise defined functions. We did not discuss symmetry just yet. It follows up next. We did not talk about 11. We did not talk about transformations yet, which is number 12. We did talk about 13. And we did not talk about 14 because we haven't gotten to inverse functions yet.
So transformations won't be on the test.
Oh, I have not presented transformations yet. Yeah, no. Okay, so so this is one document. If you'd like to start with that, and this second one I selected from here. I copied for you the review problems in chapter 2, the chapter 2 review, chapter 2 test. That's what I meant. Chapter 3 review. Not entirely pertains to this, and the practice test for chapter 3. Practice test for chapter 2. Practice. Okay. So what do you would like to start with? And this is where we start. Which one? Okay. So please choose. We're not going to be able to finish everything. So please choose. Choose whatever you want. If you recognize problems that we have covered in class, like for example, number 1, we did at least 2 or 3. Let's skip it unless you have difficulties with it and you say, let's do it. Again, problem 2 is very similar to what we covered, so please choose if you like from page 1. Number 2, okay, so let's start with number 2. So we have 2x cubed, 1 minus x to 1/2. And 2x plus 1 to negative 2/3, and then minus x squared, 1 minus x to negative 1/2, and 2x plus 1 to 1/3. Okay, how many terms we see here? Very good, awesome. And what do they have in common? They have x squared, yes. What else?
1 minus x.
They do have 1 minus x, and let's discuss which power. Which one?
1 by 2.
So I'm looking at 1/2, and I'm looking at negative 1/2, and I have to choose the smallest of the two. There is no discussion there. We always choose the smallest of the two. Negative 1/2. And then I see 2x plus 1, and the power will be?
Negative 2 by 2.
Negative 2/3. Very good. Now let's see what is left. From the first piece, I took out x squared. What is left? I completely agree. Now from 1/2, I took away negative 1/2. What is left?
0.
That's not possible. From 1/2, I subtract negative 1/2. I could never get 0. I do get 1. Very good. So 1 minus x then. 2x plus 1 to negative 2/3 is completely out. Agreed?
Yes.
Now I reach the negative symbol. X squared is completely out. 1 minus x to negative 1/2 is completely out. From power 1/3, I subtract power negative 2/3.
1.
Correct. Very good. In parentheses, please, because of the negative symbol in front. Very good. Awesome. Well done. I'm going to go to the next page because, of course, no one is surprised. I ran out of room. We know that. So this is x squared. I would prefer putting all these in the denominator. Please pay attention. One thing I may have not emphasized. It's very important where you write the equal symbol. The equal symbol and the fraction line have to be lined up. So do not write this. That will be incorrect. So the equal symbol and the fraction line have to be lined up. The denominator will be 1 minus x to 1/2, or the square root if you like, and 2x plus 1 to 2/3, or the cube root of 2x plus 1 squared. The numerator has x squared. And now let's see what we have. 2x minus 2x squared minus 2x and minus 1. These two go away. I see they are both negative, so I will factor out the negative symbol. The equal symbol, the negative symbol, and the fraction line are all lined up. My apologies if I did not emphasize that enough. Okay, so then the top is x squared 2x squared plus 1 divided by 1 minus x. If you'd like, you can put it as the square root times, and you don't have to do anything, the cube root of 2x plus 1 squared. This is the final answer. What is more important is, do we understand each and every step? Any questions? Yes, please.
I don't understand how you went from the last page to the next page where you put the denominator in.
You mean
Like where you got the
negative exponent? Negative exponent means 1 over. Negative exponent is 1 over. Anything else? Anything else? Yes, please.
Can you just scroll up a little bit?
Yes, of course.
How'd you get it negative 2x squared? In the bottom?
This one?
Yeah.
2x times 1 is 2x. 2x times negative x is negative 2x squared minus 2x and minus 1. You may see something I don't, so please don't be shy and take me back where, yes, Vanessa?
So we can't keep the charges at the bottom.
Say again.
We can't keep the charges at the bottom, we have to make it square roots.
This is good too,
Okay.
but no negative exponents in the final answer. Yes, this is fine, this is fine. Yes. Good. Anything else? Other questions here? Yes, Flynn?
So you can have like square roots and cube roots in the denominator.
You can, as long as it's a number. You cannot. So if I have 1 over the square root of 3, I will write it as the square root of 3 over 3. But if it's a quantity like this, it's okay. Especially when they do not need, I cannot multiply them. I have to change the index into 6, to multiply these two. That's okay. This is good enough for now. Yes. Because what else we can do with this is just solve for, if this is a derivative, set it equal to 0, and the denominator will not count anyway. Yes, I saw another hand, right? You want to say something?
I mean, I was just gonna say like I know why you I see you moved into the denominator. I understand the step, but why do you move to the denominator?
Any power that is negative is 1 over.
Okay, so if it wasn't negative, you would have kept them in the numerator.
Yes, I cannot move them to the denominator just to make the power negative,
Okay.
right? So if I have 2 to negative 1, this is 1/2. And I have to write it as 1/2. So the previous step was to negative 1/2. That's why it went to the denominator. If it's positive, I cannot just simply move it because I want to. But this one has negative power, it goes to the denominator. It has negative power, it goes to the denominator. Is that clear, everyone? Okay, what is the next that you would like to choose from here? So page 2. Let's move on page 2. Anything from page 2? Rationalizing should not be a problem, right? Okay, page 3. C, okay? So, okay, so we have x to the 4th minus 3x squared plus 2 equals 0. What type of equation is it? It's correct, so which is a polynomial degree 4. How many solutions will you determine? 4 solutions, excellent, good. I recommend denoted this by any letter you want because it's not only polynomial, but it's also quadratic in form. So polynomial and quadratic in form. So then t squared minus 3t plus 2 equals 0. We've done this, correct? We remember this, right? Okay. So we factor into t minus 2 and t minus 1. We get 2 options for t. What are they? Equals 2 and 1. But these are 2 new equations. T equals 2 doesn't mean anything. But x squared equals 2 is what we get from here, right? And x squared equals 1 is what we get from here. We can never forget that we need to take the square root and we will not forget the plus or minus. If we forget the plus or minus, we will not get 4 solutions total. So take the square root, and then we get x equals plus or minus the square of 2 and plus or minus 1. And that's as expected, 4 solutions. Any questions? Okay, next question.
Who do you see? On that page?
From this page?
Yes.
Okay. Any questions on this? Moving on? Yes? Yes?
Move on.
Okay. So we have negative 2, the absolute value of 2x minus 3 plus 14 equals 6. We know that this is an absolute value equation, and anything can happen here, right? A lot of options. But of course it's not cleaned up, but now it will be, in a second, it will be. Of course I have to move 14 to the other side, and I have to divide both sides by negative 2. Remember, we cannot touch the absolute value. We cannot remove anything from the absolute value. We cannot distribute inside the absolute value. We cannot factor out anything from absolute value. Nothing. So now we know we have 2 options. Either 2x minus 3 to b or 2x minus 3 to b. What can I have in here so that the absolute value is 4? 7? No. I'm just being silly. 3? No.
Plus minus 4.
Exactly. There's no other option but 4 or negative 4. And then this becomes 2x equals 7 and x equals 7 halves, or 2x equals negative 1 and x equals negative 1 half. These are the only options. Yes, Mike?
Why are they different? How did you?
Because I have to add 3 and I get 7 and I divide by 2, and here I have to add 3 and I get negative 1. Oh, inside?
Oh, I didn't see the negative.
Okay. Good. Next question. Anything else? Moving on.
Good.
I also would like to, when we're done with that document, I would like to choose from here. I have selected a few problems from this review from the end of those 2 chapters. I'm ready when you are. Number 7. Yes, let's work on number 7. Let's read it first. The monthly cost of driving a car depends on the number of miles driven. Lynn found that in May her driving cost was this for 480 miles. 380 for 480 miles. Always take notes when you work on a word problem, and you may need to read it more than once. And in June her cost was 460 for 800 miles. Assume that there is a linear relationship. This is a key word here, or key words, linear relationship, because if it's quadratic, it's something else. Between the monthly cost C of driving a car, C, and D, the distance. Find the linear relationship that relates C and D. Use this equation to predict the cost of driving 1,500 miles per month. And what does the slope of this line represent? And how many miles can she drive with $580? What is given in the problem?
2 points.
Excellent. Thank you, Mike. Awesome. Now, careful. This is very important. Remember, one variable is the y variable and the other one is the x variable. I have to think that which one is the independent.
She's changing the miles.
The miles is the independent, and cost depends on miles, not the other way around. So this is extremely important, which means that the first variable, the first coordinate must be
480.
Thank you.
380.
That's it. So be very careful when you choose. Yes, we have to order pairs or 2 points here, but you have to choose, make the correct choice for the independent and dependent variable. Right? Time is independent. You can never say that time depends on temperature or something like that. Maybe temperature depends on time. of the day, and so on and so forth. And of course, the y variable will be 380 and 460 respectively. Very good. In order to find C of D, you don't have to call it like that. You can call it f of x. It doesn't matter to me. What do we have to find first? We are told that the relationship is linear. Very good. Yes. We're asked to find, we have to find the slope first. Yes. Connor, you had a question?
Oh, no.
No. Okay, so remember y2 minus y1 over x2 minus x1. Name it. Name the points. You don't have to write it like I just did, but it's important to keep them in the correct order. So then 460 minus 380 over 800 minus 480. So the top is, I think, 80, and the bottom is it 320? So this is 1/4?
Can I ask you a question?
Yes, anytime.
Okay, so the coordinates that you have,
Yes,
so you have the distance driven of
yes,
the first
yes.
to the amount.
Of
And then
dollar,
on
yes.
the next coordinate, you actually have the opposite of that,
Those are,
right?
no.
You have the 800 miles distance driven.
So this is 480 with 380, and this is 800 with 460.
But why don't you, what, does it matter whether you have that as an x and the other as a y?
Yes. Absolutely. Because it's cost that depends on miles. It's not miles that depend on cost. The height of a person depends on the age, from, let's say, from 0 to 10 years old. Right? It's not, it's, the height depends on age, not the age depends on height. Does that make sense? Okay, 1/4, we simplified it. Measurement unit. If I leave it as is, I will not get full credit. It has two measurement units, one coming from the top and one coming from the bottom. What is the measurement unit for the top?
Dollars.
Dollars per,
Mile.
that's it. Please write the measurement unit. Dollars per mile, which is a quarter per mile. Okay, perfect. So now we determine the slope. Are we given the y-intercept? Is any of these points the y-intercept? Perfect. So then we will use y minus y1 equals the slope times x minus x1, in which the slope is 1/4, and you choose any point you want. It doesn't matter. If I choose 0.1 and you choose 0.2, we'll get the same answer anyway. Which point? Okay, so then 480 and 380. So this is what I recommend. Instead of writing parentheses and nested parentheses and inside parentheses, you may say, oh, this is not what I want to do, that's fine. But I write it underneath and then write it again, so I don't have to use a lot of parentheses. Sometimes these are negative and so on and so forth. So minus 380 equals 1/4 x minus 480. Of course, I'll distribute 1/4 x minus 120 and plus 380, and that is the equation. 1/4 x plus 260. Yes, if you want to use C, please use C of D equals 1/4 D plus 260. This is much nicer because we are told cost function of distance traveled, use C and D. It's up to you. I will not deduct points if you use a different notation. Use this equation to predict the cost of driving 1,500 miles per month. That's part B. This was part A. Find the equation. And now part B, we're asked to find the cost for 1,500 miles. That's it. C of 1,500 1/4 times 1500 plus 260. And give me that number when you're ready. In part C, we're asked to find the slope. We're asked to explain what the slope represents. This 1/4 dollars per mile. What does it represent? The rate of change of the cost for any extra mile. Right? So the rate of change. Do we have this number? 600, Ed? Thank you very much. Okay, so the slope, which is 1/4 dollars per mile. The rate of change of cost per mile. How many miles can she drive with $580? What do I do now? Excellent. Now we are given the y variable, we're asked to find the x variable. So this is 580 equals 1/4 d plus 260, a linear equation. Now, of course, I'm going to subtract. 320 equals 1/4 d, and I'm going to multiply both sides by 4. And I get 1280 and measure, oh, sorry. Measurement unit, thank you. Good, next question, is there anything else we want to go back to? Anything else?
8.
Which one?
8.
Okay, any questions on this that we just finished? Yes? Any questions? Okay, perfect. And we have f of x, the square of x squared minus 9, minus the square of x plus 7. Here we're asked to find the domain of this function. Okay, any suggestions? What do we have to write? I have a restriction for this and a restriction for this, yes. For the first one.
X not equal to 3. Plus minus 3.
Say it again.
X is not equal to plus minus 3.
We don't solve any quadratic inequality like that. Careful. We talked about it.
Oh my god.
I have to write the restriction. Do not solve anything just yet. Please give me the restriction. Do not solve anything. Give me the restriction. We just fell in love last time with this, the square root function. So you have to give me the restriction.
X squared cannot equal 9.
No, x plus 3, x minus 3.
X is greater than and equal to 0.
X squared minus 9
Greater than or equal to.
in whatever sign, 0. I don't know if it's greater
I
than.
think it's greater than or equal to 0.
Good. And the second one?
What?
We just forgot our first love from last Thursday. It didn't last too long.
X squared minus 9 is.
What is the second condition, please?
Greater than or equal to.
Good. Okay, so this one is very easy because I have greater equal to -7. This is already solved. But this one, please, we wrote that. If you need to write it again, you cannot separate the variables in an inequality if it's quadratic. And you cannot take square roots in an inequality. Please. 5 minutes ago, we had a very similar example. See how useful this is? That I can always go back when I want to. We had this example. We did not do anything else but factor it and study the sign. We did not take 4 to the other side and took square roots. We cannot do that in an inequality. Look at what we get. Completely different. This is a quadratic inequality. We cannot do that. We cannot take square roots in an inequality. In an equation, yes, I completely agree with you. I'm right there with you. So, this is x plus 3, x minus 3 greater than to 0. X is the variable in the problem. X plus 3 is the first factor. X minus 3 is the second factor, and we are interested in the product. Which number? So this is, yes, Mike?
Can you go back to the other problem that you showed?
Yes.
If we solve for, like, move the 4 to both sides and then square root it, we get the negative 2, 2.
But you don't get the interval.
So we get the,
You don't get the interval. You just get two numbers. So if you take 4 to the other side and take the square root, you get plus or minus 2. So you get x less than or equal plus or minus 2. What does that mean? How can a number be less than 2 and at the same time less than negative 2? Where is the interval? Be very careful. It's too late for us to invent something in algebra. It's about maybe 1,000 years to we're ahead of our time. Okay, I mean, we should have been born 1,000 years ago if we wanted to invent something in algebra. It's too late for us. We can invent other things, but not in algebra. Too late. So which numbers go in the table? So don't try to invent anything in algebra, please. Yes, indeed, negative 3 and 3. Where is the 0 for this one? Where is the 0 for this one? Awesome. Where is the 0 for... Okay, they're both linear functions with positive. They have to come from negative, cross the x-axis, negative, cross the x-axis, and go positive. On the first interval, positive. In the middle, negative. Outside, positive. Now, only now, we have to choose the correct interval. Which interval will I choose now? Ah, awesome. If you take 9 to the other side, you're never going to get this. So please do not take, it's not even allowed to take the square root. So then this inequality, the solution to this will be negative infinity to negative 3 union 3 to infinity. And now we have to intersect. We want the common territory of these two, the blue and the purple. I'm going to graph the blue. I'm going to graph the purple. Here is purple. That's purple. And here's the blue. Because I'm intersecting, I have to choose the territory where they both exist at the same time. Purple and blue? Yes. Purple and blue? Yes. So can anyone dictate the domain of this function? Negative 7 to negative 3 union. That's it. On this test, I know I showed several problems with quadratic inequalities, but we haven't really talked about that. We didn't get to that topic. So on this test, I would not have examples with quadratic polynomials, inequalities, and polynomial inequalities or rational inequalities, because we didn't really get to this handout yet. I showed you 3 examples, but I think I'm going to wait till I put this on the next test. Okay, anything else from here? Yes, Glenn?
Can you just review your
Yes. So we have f of x, which is 3x over x minus 1. We're asked to find and simplify the difference quotient for this function. Are you, since, as I said, I'm asking you, we looked at 3 or 4 problems with quadratic inequalities. Is that okay to put a problem like this on the test? No? Are you okay with it? All you have to do is just factor it and study the sign using the table. We had at least like 3 or 4 problems. Is that okay?
No.
You can take them out.
No. Okay, so you're ready.
Okay.
I got you.
We have 3.
Okay, next problem. Let's take a look at the difference quotient. So the difference quotient will be given to you. You don't have to memorize it, but you have to write it. So f of x plus h minus f of x divided by h. So we have 3x plus 3h over x plus h minus 1 minus 3x over x minus 1 divided by h. Exactly what we just did on the first problem. We will have to find the least common denominator. We know what has to happen when we find and simplify the difference quotient. What has to happen? Yes, Mike?
Where is the first part of it? So I know the x comes to 3x plus
F of x plus h, f of x means f of blah equals 3 times blah over blah minus 1.
Oh, you just.
So 3 times blah over blah minus 1. Is that okay?
I know that you distributed.
Yes, I have to. Yes.
So it's negative f of x, how come the denominator wouldn't change to negative?
Say it again.
So it's negative f of x, right, on the numerator?
Yes.
So why wouldn't the denominator go to negative x plus 1?
It's negative that quantity. I cannot change anything in the quantity itself. It's minus f of x. I copy the minus and I copy the f of x. I can't change
You
anything.
don't distribute the
I
negative.
cannot distribute. If I distribute, I have to distribute to either the top or the bottom, not to both.
Okay.
And I never choose to distribute to the bottom, ever.
Sure.
No. Good. So the least common denominator.
X plus h minus 1 times x plus.
Very good. X minus 1, x plus h minus 1. Awesome. So now the top needs what? Excellent. And the top needs what? Good. 2 things have to happen every time we determine and simplify the difference quotient. What are those one more time?
Everything's.
Oh, yeah, there's everything.
Yes, all terms without h must go away, and eventually.
Awesome.
Awesome. I'm repeating this just because if you make a mistake and they don't cancel, then you should say, something is wrong. Okay, I'll distribute x to these 2. 3x squared plus 3xh minus 3x minus 3h. And now I'm distributing negative 3x minus 3x squared minus 3xh and plus 3x. Let's see if we have an error. I see these 2 go away, these 2 go away, and these 2 go away. This one. So the only leftover is that. So far there is no mistake. All terms without h are gone. The numerator is negative 3h. Negative 3h over x minus 1, x plus h minus 1 times 1 over h, and I simplify, and I get negative 3 over that product. I've seen it in so many papers. You write something about the top and you forget to copy the denominator. So please do not forget to copy the denominator. Anything else from this test? Yes, please.
10.
10. Any questions on the previous problem? Are we okay with the rest now? Lynn, is this okay now?
Yes.
Okay. Anyone else, other questions? Anything? Mike?
Wouldn't it be negative 3h over x plus minus 1? Like, you have the negative 3h at the top.
Yeah.
Oh, you just took it out.
Yes, I put those in front of the fraction line. Yes. Very good. Anything else?